Welcome to the third of 3 tutorials that explain how to import and export Excel spreadsheets using Zeddy. If you've not watched the previous 2 parts yet, then please do so now. The material in this tutorial will then make better sense. As mentioned previously, the common uses for the Excel export and import functions are as follows. This tutorial focuses on the third of these. We'll be converting an Excel spreadsheet into an XML file which can then be mapped and imported into our business systems. In order for a spreadsheet to be converted to XML, it must contain control information. This information is stored within cell comments in 2 places. The control cell, usually cell A1, and the column headings row, which is usually row 4. The control cell contains information about the XML file to be created, and the column headings row comments say where to map each column into the XML structure. If the spreadsheet was generated by Zeddy using the approach described in the previous tutorial, the control cell and column heading comments will have been created automatically. If the spreadsheet came from a different source, the creator of the file will need to include appropriate comments in these cells, and will probably look to you for guidance on how to create them. The comment in the control cell contains a number of records that describe the XML structure and the keys used to generate it. An example is this. Each line in the comment contains up to 3 fields separated by an @ character. The first field is always the record type. The other 2 fields provide additional information. The possible record types are root tag, key, constant, and default. Root tag specifies the name of the root tag to be used in the XML file generated from the spreadsheet. Key is used to associate a parent tag with a combination of column IDs that make up its unique key. I'll explain what I mean by parent tag in a minute. Constant assigns a fixed value to a tag in the resulting XML. And default provides a default value to use if the spreadsheet does not contain a value in a specific column. There must be a key entry for each parent tag in the XML file to be generated. A parent tag is a tag that exists as a container for other tags but has no value of its own, and is also not the root tag. Using the XML from the previous tutorial, the parent tags would be: the unique key itself is expressed as a list of column IDs, so for each parent tag you would need to decide on the column or combination of columns that constitute its unique key. The unique key for the order tag is column A because it contains the order number. The same is true for the lines tag, as there is only one of these in a given order, but for the line tag it's the combination of order number and item code. Those values would be found in columns A and I respectively. Constant records are used to provide values for tags that are not present in the body of the spreadsheet. The supplier ID tag does not have a corresponding column in the spreadsheet, so instead the import process will always set its value to 5693270. Default records are used to provide default values for columns that may or may not be completed by the sender of the spreadsheet. In our scenario, if the sender doesn't specify a currency, we want to assume they mean EUR. The column headings in row 4 specify the XML tag into which the values from that column are to be mapped. We're going to say that Ace Vegetables have previously received a spreadsheet containing order information in the format that allows them to return delivery information. They've now completed the relevant columns in that spreadsheet and have returned it for processing. So this is what it now looks like. The spreadsheet was added to Zeddy as an inbound supplier ASNs file from Ace Vegetables. The next thing we need to do is convert it to XML format using an Excel import action. The direction for the action is inbound, and it targets supplier ASNs files from partner Ace Vegetables that have a condition of original. For the sake of simplicity, we're going to say that there's no need for metadata criteria on this action. The Excel import action is defined to process a worksheet called orders. We've set the control cell to A1 and the header row is set to 4. So ZE now knows where to find all the information it needs to create the XML. If the export runs successfully, the condition of the supplier ASN's transaction will be set to complete, because there's nothing else we'll need to do with it. If an error occurs, the condition will be set to error, and the transaction history will record what the problem was. The generated XML will be added as a new inbound transaction from the partner that sent the original spreadsheet, so Ace Vegetables in our case. We've not specified a document type here, so we'll let ZE assign appropriate value. The initial condition of the XML file will be imported from Excel. This is the XML that the action produced from our example. As you can see, it's remarkably similar to the XML we used to generate the spreadsheet in the first place, but with the delivery information tags now completed. To make best use of the Excel import action, it's useful to understand a bit more about how it works. When ZE processes a row from the spreadsheet, it needs to determine the complete key for that row. This allows it to place the data from that row at the correct position in the XML file it produces. If a key cell does not contain a value, then its value is assumed to be the last non-blank value seen in that column. In other words, what the import process uses is equivalent to having the following values in columns A and I. If a cell contains a value, then that value is always mapped to the tag specified in the column heading comment. This means that the import process uses a last value wins approach on the cells. So if cell F8, which is part of the first order, were to contain 2019-0109, then the expected del date tag for that order would ultimately contain 2019-0109, rather than the 2019-0108, which is the value in cell F6. If all the key fields in the row are empty, as is the case for row 5, then that row will be ignored. The person or the system that generates the spreadsheet could, if they wanted to, put all the key values into columns A and I, and it would have no effect on the XML that gets produced. This means that the rows in the spreadsheet do not necessarily need to be arranged in the manner shown above. If it's more convenient, the sender may choose to complete all the key cells and sequence the rows in any way they wish. They might prefer to show all the order rows first, followed by all the item rows, and then all the additional identification rows. Something like this. As mentioned in the previous tutorial, it's not safe to assume that the information entered into the spreadsheet is going to be appropriate to how it will ultimately be used. The spreadsheet could potentially contain invalid values in some of the cells, such as non-numeric values in quantity cells. For this reason, it's advisable to validate the results using a validate action before allowing the data into your business systems.